In this lecture, we will take a brief look at Bitwise Operator. In the JavaScript, we have Bitwise Operator to manipulate low-level binary representation of numbers. This operator is not commonly used in JavaScript programming, but you can take this tutorial as a knowledge. If you are not familiar with binary representation of decimal integer, then you can probably skip this video. Bitwise operator works on only integer operand and assume this operand as 32-bit integer rather than 64-bit floating point value. Now the following is the bitwise operator. First, bitwise AND operator. Bitwise AND operator perform boolean operation on each bit of its integer argument. A bit is set in the result only if the corresponding bit is set in the both operand. For example, so we have two operands here with the hexadecimal value. When you execute this statement, the result would be this. So we specify 4-bit for the first operand and 2-bit for the second operand. Now the AND operator returns only 2 bits as a result because we equally set 2 bits on the operand. Right? Now the next bitwise operator is OR. The OR bitwise operator perform boolean operation on each bit of its integer argument. A bit is set in the result if the corresponding bit is set in the one or both of the operand. For example, we have two hexadecimal values with OR operator. So the result would be this. Right? The next bitwise operator is XOR. The XOR bitwise operator perform a boolean exclusive OR operation on each bit of its integer argument. Exclusive OR means that either operand 1 is true or operand 2 is true, but not both. For example, so we have this example with XOR operator. When you execute this, you will get this hexadecimal value, right? The next operator is NOT. The NOT bitwise operator is unary operator that operate by reversing all its bits in the operand. For example, when you execute this, you will get this result or -16, right? The next operator is shift left. The shift left bitwise operator move all bits in its first operand. For example, in the operation A, then we specify the shift left operator and 1. Now the first bit of A become the second bit, then the second bit of A became the third bit, etc. Shifting a value left by one position is equivalent to multiplying by 2. Shifting 2 position is equivalent to multiplying by 4, and so on. For example, 7 left shift 2. When you execute this statement, the result would be 24. Right? The next operator is shift right. The shift right bitwise operator move all bits in its first operand. Shifting a value right one place is equivalent to dividing by 2. Shifting right 2 place is equivalent to integer division by 4, and so on. For example, 7 shift right 1. When you execute this statement, it evaluates to 3. And if we say -7 right shift 1, then it evaluates to -4. Then we have a last bitwise operator, which is right shift with 0 fill. The right shift with 0 fill operator is just like right shift operator, except that the bit shift in on the left are always 0. For example, -1 right shift 4 evaluate to -1. But when you say -1, then we specify right shift with 0 fill operator and specify 4 evaluate to this, right? That's it, our bitwise operator is completed. If you are not completely understand this complicated topic, then don't worry, it is not that much important. Okay, that is all for this tutorial. We will see you in the next one.